This video lesson is on the states or phases of matter, specifically how matter changes from a solid to a liquid to a gas or plasma, or from a plasma back to gas to liquid to a solid, and how that happens. First, we need to start with exactly what matter is. Matter is anything that has mass and takes up space. And you know, when we say takes up space, we're talking about volume. So what do you think of when you hear the word matter? First of all, it's made up of atoms. There are 4 phases or states of matter, and the atoms are always moving. Even when it's a solid, those atoms are vibrating. This slide shows a representation of how the molecules might look in the different phases or states of matter. So if we look at the very bottom at the solids, the molecules are packed real closely together. And remember that molecules are always moving, so these guys would be vibrating. Now, as we increase the energy or the heat, the solid would turn into a liquid. Now the molecules are a little bit further apart, and they're just rolling over each other. If we continue to increase the energy or the heat, the liquid would turn into a gas. Now the molecules are moving really fast, and they need a lot of space. Now if we continue to increase that energy or the heat, it turns into plasma. And plasma is electrically charged because they lose their electrons. Now we're going to look at each one of the phases or states of matter separately, beginning with solids. And solids have a definite shape and a definite volume. So if you take a look at this shape of this cube, it doesn't matter how I move it around, it's not going to change, and the volume is going to stay the same. What does it mean that it has a volume? Remember that volume means how much space it takes up. And in a solid, even if I move it around, that volume is going to stay the same. In a solid, the atoms are packed tightly together. They have very little energy. Those atoms are just vibrating in space because remember, molecules don't ever stand still. Those atoms are always moving. The liquid phase of matter takes the shape of their container and has a definite volume. So as you can see, these molecules are just rolling over each other. That's so they can pour. So look at this cup of milk. It took the shape of the glass, but the volume, how much space it takes up, remains the same. So it has a definite volume. Liquids have atoms that are loosely packed, and they have more energy than they did in a solid. And those molecules or atoms are just flowing over each other. Now if more energy or heat is added to that liquid, it turns into a gas. And in gases, they take the shape and the volume of their container. They're going to spread out until they fill that whole container. So if you look at this balloon, it's filled with the gas. So the gas in there is going to take that shape of the balloon, and the amount of space it takes up depends on what its container is. The molecules are moving extremely fast and need a lot of space. In a gas, the atoms have a whole lot of energy, so they're bouncing off whatever they're in, moving about, and have a whole lot of space, so they are a lot less dense than our liquids and solids. Plasma has atoms that are electrically charged. The electrons tend to separate from the atom. Plasma is the most common state of matter in the universe, and it has an extremely high amount of energy. Fluorescent light bulbs, neon signs, the aurora borealis, and lightning are all made of plasma. Now I want you to take just a minute and ask yourself, what does it take to move from one state or phase of matter to another? How does it turn from a solid to a liquid to a gas to a plasma? What does it need to move from one form to the other? If you said adding or taking away energy or heat, you're correct. Remember that when we talk about energy, we could also be saying heat. So if we look at this right here, as energy or heat is added, a solid turns to a liquid, turns to a gas, turns to plasma. Then likewise, if we take energy away, it goes from plasma to gas to liquid, back to a solid. When energy or heat is added, those atoms or particles move faster. Now notice I use the word particle. When you see the word particle, I want you to think atom. So if you look at the solid right here, those atoms are just vibrating. And if we add energy or heat, those molecules speed up. So now they're moving more freely and flowing around each other. And if more energy or heat is added, those gases are just zooming around. A whole lot of energy and need a whole lot of space and become less dense. When energy or heat is taken away, then the atoms and particles move slower. So if we take energy away from the gas, then they slow down and now they're just flowing over each other. That would be the liquid phase of matter. Then if we keep taking that energy or heat away, it's going to turn to a solid where those molecules are really moving slowly. They're just vibrating against one another. If we look on this side, it's adding the energy. And if we look over here, it's taking the energy away. So if we start with the solid and we add energy or heat, then the solid begins to melt. And when it is fully melted, it becomes a liquid. Then if we keep adding that heat, that liquid evaporates and becomes a gas. Now if we take that gas and we tend to take away the energy or that heat, then it condenses and turns into a liquid. If we keep taking that energy or heat away, that liquid will freeze and turn back into a solid. When I talk about adding energy or heat, energy is being absorbed when change of phase is going in this direction from solid to a gas. Energy is being released when the change of phase is going in this direction from a gas to a solid. This is a time temperature graph for water, and it shows the temperature going up or down. So it's adding or taking away energy or heat. So if we start down here at minus 20 degrees Celsius, now remember in science we use Celsius. In America we use Fahrenheit, but in science we always use Celsius. So if we start down here at negative 20, then that water is in the form of ice. As we hit 0 degrees, it's both. If we go down, it's ice. If we go up, it starts to melt. So 0 degrees is our freezing point and our melting point. Now, as we add energy, as we go this way in the graph, we're adding heat or energy. Notice how right here, the temperature doesn't change. Even though we're adding heat, the temperature doesn't change. That's because it's ice and water. So as long as it's ice and water, it's still going to be 0 degrees. Then, when it actually hits right here, you're going to have a phase change, and it's going to turn completely to water. When there's a phase change, now the temperature can go up. So as we're adding our energy, the temperature now is rising within that water until it hits 100 degrees Celsius. Now, look again how the temperature stays the same. As long as it's water and steam, think of a pot of boiling water on the stove. It's water and you can see the steam rising. So as long as it's still water and steam, it's going to stay at 100 degrees. When it hits all steam, that's when it hits that phase change. Now it turns totally to gas and the temperature can go up again. So, just to recap, right here was where we had our phase change and the temperature can rise. It changed from a solid, ice, to liquid, water. Now the temperature can go up. Then when it hit right here, we had another phase change, and it went from water completely to steam. Now the temperature can rise again. So notice that the temperature does not rise until there is an actual phase change. Look at the different temperature scales: Kelvin, Celsius, and Fahrenheit. Fahrenheit's what we use in America. Celsius is what we most commonly talk about in science, but Kelvin we also use in science. Now notice at absolute zero on the Kelvin scale, that's where molecules would stop moving. Water freezes at 273, 0, and 32 Fahrenheit. Water boils at 373, 100 degrees Celsius, and 212 Fahrenheit. You guys did a great job listening to this video. Make sure that you save your notes and bring them to class.